In this section, you're going to learn how to calculate something called molarity, which is a unit of concentration. When we talk about concentration, that's a measure of the amount of solute that's dissolved in a given quantity of solvent to make a solution. Hopefully those vocab words sound familiar to you. The solute is what's dissolved into the solvent, usually water, to make the overall mixture, which is called a solution. Now, a lot of times we use really relative terms for this, like dilute. Dilute means that there's not a lot of solute in the solution. And the opposite of that would be concentrated. Concentrated solution contains a large amount of solute. But what's small and what's large? I mean, if you have a gram of solute, that's a pretty small amount. But if you dissolve that in like a milliliter of solvent, then that gram becomes a large amount of solute. So when we say the words dilute and concentrated, those are pretty relative terms. We need more specific units, like how much solute is there in the given solvent or in the given solution. And molarity is our most common unit that has specific units attached. Molarity is defined as the number of moles of solute dissolved per 1 liter of solution. So we always want to think about this as a conversion factor. So you want to think about this as a conversion factor in order to calculate the number of moles per 1 liter. Let me see. There's our most important unit of concentration. You're going to see the units are symbolized with a capital M, and you probably have seen this in the lab already. Back when we were doing labs, you might have been directed to use a capital, 6 capital M HCl, which stands for a 6 molar solution of HCl. Molarity can be in any number. So we might have 6 molar or 0.1 molar, 1 molar, 0.5, 3. It can be a fraction, 0.833 repeating. It doesn't matter. It's what you get when you divide the number of moles by the volume of the solution in liters. So let's do a couple of examples. What is the molarity of a solution made by adding 2 moles of HBr to make 0.5 liters? Now, whenever you see that, what is the molarity or what is the concentration, I want you to think about and maybe even physically put down immediately X moles per 1 liter. That's what you're solving for. How many moles? What is the molarity? How many moles are there in every 1 liter? And we're going to set this up kind of like a ratio, okay? So how many moles are there in 1 liter when I have 2 moles in 0.5 liters? And so to solve for X, you can think about this as like cross multiplying if that's how you do it, or I think it probably goes this way, but either way, since we're solving for X over 1, you just need to take 2 divided by 0.5, and this would be a 4 molar solution. You can either write that as 4 capital M or 4 moles over liters, either way. The next example says a solution is made by dissolving 3 moles in 750 milliliters. What is the concentration? And since we're going to solve for concentration in terms of molarity, again, always think about that we're going to solve for the note X in moles per 1. So we can fill in the other side of this by saying, well, how many moles do we have? There are 3 moles in this problem. Notice this doesn't even tell us what the solution is made out of. It doesn't matter. It's 3 moles of whatever it is. Molarity is independent of the identity of the solution. 3 moles in 750 milliliters. So because I have 1 liter over here, I need to have the matching units. I need this to be in liters. So to go from milliliters to liters, that's 3 steps to the left on the staircase. So we're going to divide by 0.7. That also gives us a molarity of 4 which I wasn't thinking about when I made these example problems, but either way, we're going to get the same answer. It's a different number of moles, a different volume, but we end up getting the same ratio of moles per liter as in the first problem. So that's a good example of how we can get the same concentration with different quantities. Example 3 is an extra step to problem 3. This time we're given 20 grams of NaOH is dissolved in 2 liters. Find the molarity. But see, we're still solving for molarity, so we still want to think about that X moles per 1 liter. How many moles do we have? How many liters do we have? I can easily say there are 2 liters in the problem, but I don't want to put grams here. I need to solve for moles first. The problem told us that the mole weight is 40, so remember you're going to do, that means that there are 40 grams per mole, which means I have half a mole here. Divided by 2. This time we don't get 4 because we're doing a half divided by 2, not 2 divided by half, so we get 0.25 molar in this case. In the final example, this one is slightly different. This one tells us that the solution is 3 molar. How many moles are present in 3 liters? So here the molarity is given. So this time we are not going to put X over 1 because we're not being asked what is the molarity. We're being told the molarity is 3 moles over 1. So the difference here is this is not the question, it's the given. So we are told there are 3 moles per 1 liter. The question is asking now for us to solve for how many moles are there in 3 liters. So be careful that you read that carefully. And the answer here is there would be 9 moles in 3 liters. And our answer isn't in molarity anymore, it's in moles. So you've got some practice in practice 8.2. Give those a try. Check them with the answer key. Let somebody know if you are struggling or need help.